Hi, we're group 32, and we're going to do problem number 4 from last week's homework assignment. I'm Kyle Smith.
I'm Jinhong Tang.
And I'm Yang Qingdong.
Okay, so problem number 4 was we were supposed to reconsider the water rocket problem from the previous week's homework. This week we wanted to create a dimensional analysis of if we were to use that in an experiment. So for this we want to make a function for the time the rocket remains in the air. So the way you would write out that type of function, and since this is about the time, you start off with time and air on the left side of your equation, and then you want to create the function with all the parameters that that problem incorporates. So for this we want to consider the height of the water initially in the rocket. We want the initial pressure in the rocket, or in the bottle. We want to consider gravity and the density of the water. So with each of these variables, we have to create dimensionless, we have to create them all to be dimensionless. So we'll start off first with time, which has units of time. We have h, which has units of length, pressure, which has units of mass over length times time squared, gravity, which has units of length over time squared, and finally rho, which has units of mass over length cubed. And we now use each of these to reduce the rest of the equation. So we start off with length. We'll just use h for our length. Then we'll use time. And you don't want to use anything on the left side of the equation. So we'll come down here and use this gravity equation. So to get time, we want to multiply by the square root of h over g, because you have to cancel out the L with this h, and to get time without the square, you have to square root. Oh, and I forgot, since we use this h here, we want to cross it out, and we use g here, and we cross that out. And finally we need to define our mass, and we'll use rho. So we just take rho times our length unit cubed. Cancel out the length cubed, and you get rid of rho. And then we want to make our pi groups. So for our first pi group, we'll use this, or time, since this one is left, this one is left. Those would be our two pi groups. So for time and air, we need to divide by 1 over t, since it's in units of time. And since our time unit, our time definition is right here, we just do divide by time, which is square root of h over g. And for our second pi group, we'll use this pressure. And pressure is in these units, so again we need to multiply pressure by L over T squared divided by M, so they all cancel, which is equal to our length unit, which is H, so we'll do pressure times H times our T squared unit, which would be H over G divided by our mass, which is rho times H. And then after canceling out units, or canceling out variables, you get pressure over rho GH. Let me erase this. Then all we have to do from here is write our final equation, which is pi group 1 is equal to pi group, or is equal to the function of pi group 2. So it's just T there